Hello everyone. Today our presentation topic is trajectory prediction. My name is Yiming Han and this is my partner Xiaoying Xin. Let me introduce the background of our project. Trajectory prediction of planning is very important in autonomous driving. Intuitively speaking, the work is to infer the future trajectory based on the his information. However, in reality, the road situations are changing and complex, so it's unreliable to predict only a single trajectory. It's important to learn drivers' driving pattern. We want to know how they drive. Moreover, this is a multimodal pattern. Longitudinal and lateral direction are orthogonal. For example, a driver intending to overtake another vehicle may do so by switching immediately to left or right lane, while at the same time he can choose reduce the velocity to wait until another car passes or accelerate to surpass another car. Look at this picture. You have 6 choices: keep lane, brake, or accelerate. This is some related work of our work. First of all is the Hidden-Markov model. The LKI is the log likelihood of vehicle I of the maneuver K. This work inspired us to classify vehicles' motion into segmentically interpretable maneuver classes. This is AMI is the predefined maneuver class of maneuver class K, and theta is the parameters of the HMM, including the state transition probabilities and the means, variance, and weights of the mixture components. They are estimated using EM algorithm, the Born-Welch algorithm. For different kinds of maneuver classes, we output different probabilities. Then is the CVAE model. It's a conditional variational autoencoder. SY is the observed dataset, and Z is a discrete latent variable. What we want to learn is the PDF of PYX, so we need to model P psi YXZ and P theta ZX. The output of encoder is the PDF of XZ, and we use it as decoder's input together with X. So then we can get PDF of XYZ, and then we fit them to maximize the likelihood of theta XY. Then we can got the theta. Here is a deep learning model, very famous. That is very famous. The transformer, because transformer is a typical sequence model. The model inspires us on how to solve the interaction between different vehicles. Look at this one. XY, we have 5 time step T1 to T5, and the different color rectangle represents different vehicles. So this work inspires us that we can concat the different vehicles' history trajectory at the same time together and use it as our model input. Here is our task. Generally, our task can be summarized as this page. We are given input dataset X and Y. Then because X, Y is the orthogonal direction, so we want to model a bivariate Gaussian distribution of it. The theta is the parameter of this bivariate Gaussian distribution. Represent the point in the parameter space. It has 5 dimensions. We want to find out the theta. Therefore, the learning process can be summarized as Formula 1. Maximum likelihood. Choose the theta that can maximize the joint distribution of BYX. Then we apply negative log to Formula 1. We got Formula 2. The X is our input data, Y is the ground truth. Based on the structure of multi-lane freeways, we assign 6 maneuver classes to help the prediction process. So the process is first estimate what m based on x, and then based on mi and x to estimate y. Then our next step is to learn how to model p, yms, and pms. This is our model. We choose the neural network to model it. There is many related work about using LSTM in this topic, but the baseline model predict the maneuver class and trajectory separately. However, we think the prediction of maneuver class and the trajectory using the same input information, so we merge them together. And fortunately, we get relatively same performance and with high efficiency. For our model, this is our model. The input is S sequence composed of ego cars and its surroundings. Embedding layer is a fully connected layer with ReLU. Output of encoder will pass to softmax layer. The softmax output is the lateral and longitudinal probabilities. Their product is the PMX. Based on the output maneuver, we can count one-hot encoding of M with encoder's output and pass it to decoder LSTM.
Okay, finally, I will show some experiment results. We use the public available dataset US101 and I-80. The datasets contain trajectories of real freeway traffic, and we split the data into segments of 8 seconds. The first 3 seconds are regarded as the track history, and we want to predict the trajectory of the next 5 seconds. Since the prediction output is a distribution, we use 2 metrics for the model, RMSE and NLL loss. For the RMSE loss, we compare the predicted trajectory with a maximum probability to the ground truth. And we compared our model with 2 baseline models. Both of them utilize the LSTM backbone structure. Here are the results of the experiments. We sampled the output into 5 seconds. From the table, we can observe that the loss increases with time step. It is intuitive that it is much easier to predict the near future. And MLSTM achieves better performance in terms of NLL, and CSLSTM is better in terms of RMSE loss. Our model can achieve similar results compared with the baseline models. But our big advantage is that our model is much simpler on structure and takes significantly shorter training time. So with good efficiency, we did not sacrifice the performance. So next, I will show the studies on training time. By combining the maneuver prediction branch and the encoder-decoder branch, we reduced the training time by 82.8%. And to further speed up the training process, we first pre-train with RMSE loss, and then we fine-tune it with NLL loss, because RMSE loss calculates much faster than NLL loss. And we also studied the maneuver prediction accuracy to show that combining the 2 branches does not influence the maneuver prediction, since the history trajectory encoding for the 2 parts are actually similar. So we can just reuse it on the 2 subtasks. And finally, here is the visualized result. The car in the red box is our target. We draw the history trajectory of the surrounding cars, and the blue line is the predicted future track. And it shows that our prediction results is very reasonable. And that's all. Thank you.